Okay, so it is also important to note this in universal quantification. So when the domain is empty, then the universal quantification is true. Okay? True yan siya. Okay, let me just rewrite this one. Is true for any propositional function p of x. Because wala namang element of x in the domain na makapagsasabi that p of x is false. So again, automatically true ang universal quantification if the domain is empty. When I say the domain is empty, wala elements sa sets. Okay? Now, meron din tayong tinatawag na counterexample. So, ano to siya? Okay, so we have to remember here that yung truth value of the certain quantification, it can be either universal or existential, nakadepende talaga yan siya sa domain. So, one way to show that p of x is not always true, kasi yun yung rule ni universal quantification, diba? That always talaga true yung predicate. So, how can we show that it's not always true? So, masasabi natin that it's not always true when x in the domain finds the counterexample of the statement universal quantification form. So, note that kahit isang counterexample lang, that's all we need to establish that a certain statement or proposition is false. So, how do we identify the counterexample? Okay, so let's have an example here. So, let q of x be the statement x is x is less than 2. So, what is the truth value of the quantification, this symbol or this form, where domain consists of all real number? Okay. So, alam na natin yung quantification niya, this one. All we need to do here is identify the truth value using this quantification for all x in the domain q of x is true. Okay. So, let's prove true ba siya or false. So, alam naman natin that the domain consists of all real numbers. So, it can be any integer. So, let's try. Let's assume that our q of x here is, let's say, q1, q2, q3. Okay, let's try each of these propositions. Let's start with proposition 1. So, if our x is 1, and we're going to use this statement here, 1, okay, wait, let me change my ink color. So, let's set x to 1. So, 1 greater than 2. So, is 1, less than, is 1 less than 2? Yes, it is less than 2. So, the truth value of proposition 1 is true. Now, how about proposition 2? So, our x here is 2. So, 2 less than 2. So, is 2 less than 2? No, it's not. It's not less than 2, right? So, this is false here. So, dyan pa lang, meron ng isang false. We already found out the counterexample of this statement. So, isang counterexample lang for the universal quantification, it is automatically considered false ang truth value niya. Okay? Now, let's have another example. What is the truth value of for all x in the domain p of x, where p of x is the statement x raised to 2 less than 10, and the domain consists of mga positive integers not exceeding to 4. So, ano ba yung mga positive integer not exceeding to 4? So, we have 1, 2, 3, 4. Okay. So let me just write this out. Since our predicate is p of x, so this is p of 1, p of 2, p of 3, p of 4. So let's try to solve each of these proposition. So proposition 1, 1 raised to 2, that's equals to 1. So is 1 less than 10? Yes, so this is true. 2 raised to 2, that's 4. So 4 is less than 10? Yes, so this is true. 3 raised to 2, that's 9. Is 9 less than 10? Yes, it is, so that's true. 4 raised to 2, that is, yeah, 16. So is 16 less than 10? No, it's not. So this is false here. Therefore, this is the counterexample of this universal quantification. Okay. Okay, thank you so much. So that's all for this video tutorial. And for the existential quantification, I will upload another video tutorial for this topic next week. And also, I'll be posting a take-home quiz for you to answer about predicate logic and universal quantification in the classroom. So kindly check it out. So thank you so much. That's all. And if you have questions and clarification, just PM me through the messenger or maybe mention me in our group chat. Thank you so much. Enjoy the rest of your week. Bye.